This is an OpenChain webinar, and as usual, we're a very informal group. What we like to do is to make sure everyone can access our discussions, the information. People who are dialing in live today have an opportunity to ask Nick questions directly. People who are watching the recording can leave comments or send emails, and we'll get them to Nick to be answered. This is a Linux Foundation webinar, which means that we are going to show the Linux Foundation antitrust policy notice. We show this at the beginning of every meeting. You can find our full antitrust policy on the Linux Foundation website. If you have any questions, you can ask them of our counsel, Andrew Updegrove. And if you're not from an LF member, of course, you can direct questions to your own counsel, if any. By the way, Andy is a novelist and has written 6 novels. So he's not only a lawyer, he's a writer. Just a tiny tidbit to make the antitrust policy notice more interesting. Our speaker today is Nick, who I've had the pleasure of meeting several times. Nick is an expert in AI and legal frameworks, which seems like a bit of an understatement given that he's been at the formative point of this field. He's now leading a company called fastcatalog.ai, and that's looking at AI supply chain management, which of course is hugely interesting to us. We have an AI study group that meets for 2 hours every month. That's chaired by Dave Marr from Qualcomm and Matthew Crawford from ARM, and has a wide range of participants discussing exactly how do we manage compliance matters in the AI supply chain. Now, Nick has a history of dealing with things at scale. As an assistant general counsel at Microsoft, he has been at the forefront of, as I said, the emerging field of AI, machine learning, and of course, other aspects of open innovation. One of the great things about Nick is that he's a person who has a background in technology as well as law. So he's one of those engineer lawyer types that we regard as extremely precious in our field, that can genuinely understand the technology and explain the legal ramifications and consider the strategic matters. So we're quite lucky today to have Nick here. The recording that we're making of this webinar will join our growing corpus of AI webinars in the OpenChain webinar series. And what we're trying to do, what we're trying to accomplish with all of this is to give a universal, freely available resource to the global community so that if they have questions about AI in the supply chain, about law, about compliance, about how to manage all of this, then we can try to give them a starting point in dealing with it, dealing with some of these questions. And before I hand over to Nick, I'll just point out the existing webinar series to give you context. As you can see, we've had webinars on GitHub Copilot. We've had webinars on the EU AI Act. We've had webinars on the Open Source Initiative's definition for AI. And very recently, we had a webinar on the current legal landscape around AI. Now, when it comes to today, the role of data in the supply chain of AI, we're filling in an important gap in our portfolio. And with that, I will hand over to Nick, our presenter, who's kindly sharing his knowledge live to people watching this on Zoom and elsewhere, and recorded in a way that will be permanently available. Nick, over to you.
Thank you, Shane, and thank you, everyone. It's a pleasure to meet you. And so thank you for the very kind introduction. I do have a background in trying to think about these issues from a legal standpoint. Just to give you a little bit more color, when I was at I was at Microsoft for 11 years, starting in Brussels in government affairs and working on technology regulations, then moved to Redmond. And in 2020, so 4 years ago, I launched a central legal function to review the use of data for training AI models. And so dealing with questions such as, data scientist has found a data set on the internet that they want to use to train an AI model. Can they do it? Is there any legal issue? They want to reuse an existing model. Can they do it? So I left in March 2024 of this year, so a couple of months ago, because I thought that there was a need in the industry to kind of think about this issue perhaps more in a more structured way. And so I launched this company, fastcatalog.ai, to provide technology and services around this issue. So today we want to talk about the role of data in the supply chain of AI. And so supply chain of AI is, perhaps a confusing word. What do we mean by that? I think at a very high level, if you ask different people, you may get different answers. So we're just going to try to level set a little bit about what is AI and what are the different components that are relevant in there. And we are basically companies like yours are trying to commercialize products or services with that are powered by AI. This is sometimes called an AI system, trying to commercialize that in different markets with different capabilities. And so one of the way that we can think about that process is we can think of this as 4 steps. Logically, first you want to source the relevant components, the relevant materials that would be necessary to build these AI systems. Then you want to assemble them, you want to build them. Once you're satisfied, you want to deploy them in the relevant markets, relevant jurisdictions for users to use them. And then there is this kind of step, which actually, is at the end, but should really be at every step of that process, which is, how do you manage that overall? What are the things to keep in mind? And so there are today we're going to look at these issues and explore how the supply chain, so the sourcing component here, if you will, so what the components that people are going to use to build their models, how they are relevant at every step, and how every step is going to influence how you think about the supply chain of AI. First, let's focus on the build phase and really trying to have a very, very simplified view of what does it mean to build AI? Like, what are the components that would be involved at a very, very high level? So please be kind and patient. This is super simplified. So if you ask anyone, they're going probably to have a different perspective on this. But I think conceptually at a very high level is going to be helpful to understand what is involved and which pieces does what. So to build an AI system or to build an AI app, here at the bottom, you are going to basically in a simplified way, you're going to take data, train a model on it using a training framework, and you're going to get an AI model. Basically something that's going to take inputs, like a text, and is going to take to give you some outputs, perhaps another text or an image or some audio for generative AI, or maybe for a classifier is going to give you the input is an image, it's going to give you a description. But at a very high level, in a very simplified way, you start with data, you end up with the model, and then you take that model and you embed it in your system. So that's kind of the training, if you will, of an AI model. Sometimes we talk about fine-tuning. And so that's a slightly more complicated process, although it's cheaper in terms of compute resources that are involved. You take an existing model. So for instance, you want to recognize, I don't know, cats in pictures. So maybe you take a prior existing model that is great for describing things. any sorts of things. You take a prior existing model, you take some pictures of cats, and you fine-tune the existing model on the pictures of cats that you care about. And then you have a fine-tuned model who's going to be great at recognizing cats. Very often, it's a good idea to do fine-tuning rather than training from scratch. And when you consider each of these large buckets, if you will, data, prior AI models, training frameworks, you're going to have each time things that are, let's say, publicly available or that are provided by third party. So we're going to see examples of that. So you're going to have public data. You're going to have perhaps your own data that you want to use for that process. You're going to have also open source AI models, and we'll see. We won't discuss all the intricacies of open source AI models, but we just touch on that. Or you're going to use private AI models like the ones from OpenAI. You're going to take that, you're going to train your new model, and then you're going to be able to use that in your app. And so all of a sudden, we see that we are using components from different providers. And so you have to think about what does it mean to use these components by others? What are the steps that you need to manage that these aspects? And just to perhaps put more, give you more, and probably you know all of this, but just to level set a little bit on the kind of market players in this field. So when you think about AI training frameworks, so how do you go from data to model? You have kind of different technology the technology stacks that are available. Perhaps you've heard of PyTorch, which is an open source framework for training models based on data. You can also fine-tune models using PyTorch. OpenAI offers fine-tuning capabilities as well. So they don't do the training for you, but they're going to fine-tune their own models to fit their need, to fit your needs. So they offer this capability. TensorFlow is another open source framework that does that. All this is going to run on certain hardware. For instance, you have NVIDIA, which is the super huge player in that field that provides hardware for AI. And then Azure, which is one of the leading cloud providers, kind of bringing everything together to do this compute tasks. So for instance, OpenAI runs on Azure. But that's just the infrastructure, if you will. That's not really the raw materials, if you will, that are going to end up in your model. And I use end up very loosely. So these raw materials are going to be the data. So not all the data will be in the model, but kind of a summary, if you will. You can think of the model as a summary or the data compressed in a particular way. And so you have the data is available on, you have certain platforms. So GitHub is actually a very large repo of public data sets, open data sets. A lot of data is available on GitHub, even though it's not super suitable for that, but it's there. You have, I think, 400 million data sets on GitHub, like big, small, all kinds. You have Hugging Face, which is, of course, a critical player, which hosts a lot of data sets directly. And then a lot of hosting actually happens on AWS. AWS provides critical infrastructure for hosting, in particular, very large data sets. We're going to see that in a minute, one example. And Azure is also well known for model hosting. So if you want to take, for instance, a model of Hugging Face, you can deploy it in Azure and run it there. And then you have the providers of models. So OpenAI is well known. You can take their models and perhaps deploy them in Azure or elsewhere. Anthropic AI is also a well-known player. Meta or Meta AI has really, I think, is the leader for providing open models, especially text models, LLMs. And so that's another player there that is extremely important. And so if we bring it back to our previous chart, just to kind of put things into context and have a better sense of who does what. So for typically, the public data would be hosted on Hugging Face or GitHub. You have actually a lot on S3 as well. you're going to host your private data perhaps on your favorite cloud or on your own infrastructure. Meta is a key provider of open source AI models. OpenAI and Tor provide private AI models. To do the fine tuning, you can use these open source frameworks like PyTorch or OpenAI, which is it's not open source, but they do provide fine tuning services. Or if you want to train from scratch, typically PyTorch or TensorFlow would be the frameworks that would be used. And then you deploy your app and you're going to run it on the cloud. Is that making any sense so far? Feel free to interrupt if you have any question. I don't see the chat chain, so feel free to interrupt if you see a question.
No,
Otherwise, I just continue.
it makes a lot of sense, and it's very useful to have this summary. At the moment, this pipeline of the build stage, I think, is not so well understood. So it's very good to run people through it. Later, of
All right.
course, there'll be some questions about things like the models, which I have
Yeah.
a couple, but
Yeah, when we come to that. And so today we are not going to focus on the compute infrastructure. We are not going to focus on the training frameworks. We are going to focus on these raw ingredients, these things that are going to, or parts of it, are going to end up in your AI model, in your product that you're going to distribute. And so perhaps you've heard of litigation. For instance, the New York Times has sued OpenAI because the New York Times has found that there was some of their articles in the public data that has been used to train the OpenAI models. And so when they use the model, they find some of the articles in there that are generated, or not the articles, but things that look like a little bit the article when they twist the arm of the model in a way. So the data is one ingredient, if you will, of AI, and so that may end up in the model. So that's something to keep in mind. Models like Llama may end up as well. Like if you fine tune, you're going to reuse certain layers. So for instance, if you think of a model of, let's just say 10 layers, right? Maybe if you do the fine tuning, you're going to keep the first 8 or 9 layers, and you're just going to change the last one, the 10th layer. So it's a lot lighter than doing a full training. You're just going to train, if you will, the last layer. But it means that you're going to reuse, the bulk of your new model is actually going to be very, very similar to the original Meta Llama model. And so that's also something that's going to be found in your new model. So this is going to be an important ingredient as well. So in terms of supply chain of components that may end up in the or parts of it that may end up in the final product or service that you're going to commercialize, the data always, and the models when you fine tune based on the model, is going to be the things that we care about. The training framework is not really going to be a component that's going to end up in your product. And the compute, of course, the hardware is not going to end up in your product either. So we're going to focus on this top layer, if you will, and we are going to look at the sourcing, like the supply chain of this. What are the things that we need to look at when we consider these components, and when the technical teams, the engineers want to use these components to build their AI systems? What are the things that are relevant? And so I thought perhaps I just give you a few examples of these public materials, these public assets that are used to build AI, and see, it's you're going to find the issue very quickly and see, how the issue presents itself. So I don't know if you're familiar, but Common Crawl is basically a dump of the internet. So they run crawlers of the internet every month or so. And so they build, they basically copy the whole internet, and they give you an archive. So today it's 400 terabytes of content, so pure text. We can go quickly and kind of see, how it presents itself. So that's the Common Crawl. It's a non-profit. you can access the different so the data. So the latest scroll will be this one. And so if you want to access it, you actually, this is because it's so large, it's actually hosted on AWS S3. And so you kind of have to run a script to download it on your computer. But that's it. If you want to have a copy of the entire internet, you just download that 400 terabytes and off you go. You have one of the critical, in just 2 lines of code, you have one critical component of the data that is used to train OpenAI, Meta, Llama, and a lot of the LLMs that you see out there. So Command Crawl is really a critical component. You just download it. There is a license though. So if you want to look at the website, they make the data available under certain terms. They actually have prohibited use about how you're going to use the data. They have certain disclaimers because, of course, they scrape the content. It's not their own content, but so they kind of give you this notice. Hence the litigation with the New York Times and others. And so on and so forth. So that's not, even though this is publicly available and you can download and, it's not really an open source license like we are used to in the open source world. It's, it's not like MIT or CC something, even though they call, Common Crawl like CC or whatever. But it's not, so it's a limited license. It's a custom license. And when I was at Microsoft, I did a little bit of statistics. If you take the universe of data sets that are relevant, broadly speaking, for AI, let's say you have, I don't know, 20,000 data sets that are relevant, and you look at the distribution of licenses and, which data set is under an open source license and which data set is under terms that are custom, that are specific, for instance, like this Command Crawl, it's not an open source license. You will find that only 20% of the data sets are under open license. The others are under custom terms or no terms. They're just shared without any contractual language. And so you are, you have to rely on other framework than the contractual agreement to use the data. So for instance, in the US, we rely a lot on fair use defense to use the data. That's not necessarily available in other jurisdictions. Let's look at the Red Pajama data set, an interesting data set, very large data set, which is done by an organization called Together Computer. And interestingly, this data set is actually available under an Apache license. I was hoping it would be visible here. It's not, but if you go to their GitHub page, you can see the Apache license here. It's an open data set. Sorry, I'm clicking around. Just wanted to show you something. However, when you dig a little bit deeper, you realize quickly that this is actually based on the Command Crawl. And so they take certain specific Command Crawl dumps. They kind of filter them, arrange them in a different way. They do the deduplication. They do all sorts of processing. And they provide you with this, interesting data set. But, how does it work? Because Command Crawl is under certain terms. These ones are is shared in Apache. So it's not really clear. Like if you try to use these things and you want to have legal clarity on that, you're not going to, you're not going to be able to reach a final answer. And so you're going to learn to navigate that. Another interesting example is book corpus. And so that's a data set which is publicly available of books. So, if you want to use this, and this may be used to train models. I don't want to share too much, but so you're going to have to navigate the copyright question because a lot of these things are going to have copyrighted materials. Another interesting example is, for instance, the Lion dataset. This is a dataset of images. So it has 400 million images. And so when you look at the data, the website. I won't go there in the interest of time, but it's under CC by 4, but not the images. This is only their like collection, their own. So that's for the data. For open source models, you have Llama, which is a popular model. So that's a text-to-text model. You provide text as input, like a prompt, like you would do with ChatGPT, and gives you an answer. Interestingly, so it's a meta-specific agreement called the Llama 3.1 Community License Agreement. And I just highlighted interesting terms here, which says that you have to display built with Llama if you use Llama, a model which is based on Llama. And there are lots of them. There are hundreds of them. So something to keep in mind when you think about sourcing these components. All of a sudden, you realize that it's not really the open source world where you had notices and attributions and perhaps other restrictions, but you get with AI, you get different types of restrictions that you have to think about. Another interesting model, which is super popular at the moment, is the Black Forest Flux model, which is used to generate images. And so you provide a prompt and it gives you the corresponding image. So it's available on Hugging Face as well. I'm going to go quickly in the interest of time, but just to give you a sense of the complexity of these things. So it's they provide non-commercial use restriction in their terms for use of the model or of derivatives. Like you fine tune, that's going to be a derivative. And you have thousands of variants out there, and there are any sorts of terms based on Flux. So if you're interested in image generation, perhaps not a super common scenario, although it may become more common for companies, very popular with certain folks, you're going to have to learn to navigate that. Any questions so far?
No, not right now, but I do have one related to data provenance, but that's probably for the end.
Well, tell me now, and if it's in one of
Okay.
the slides, then yeah.
Okay, so one of the things that's come up quite a few times is that a lot of the models seem to be huge, but slightly mysterious about where they're pulling their data from. And,
Yeah.
what are they scraping here? And this sort of takes us to the New York Times. And there's been some interesting assertions by some players in the AI field that essentially the web is public domain. You can go there and you can take stuff. Which seems like an assertion that can make, let's say, traditional supply chains, infrastructure providers, and so on, very nervous. Because the last thing you want to do is, let's just pick Japan as a hypothetical. The last thing you want to do is to be in a situation in Japan where you have, let's say, smart houses, and where you will always be liable for the smart house technology, which, for example, you can't change um, a Linux-based air conditioner in Japan. The reason is that it has to be DRM protected, because if you change it, if you said, I did it, I made my own toy out of it, it doesn't matter. The manufacturer is always liable here. Now, that's a simplification, but if you ship something in a place like Japan, contains AI data, contains someone else's alleged copyright material, suddenly you're very liable. And that's where the provenance of data seems to be a big question, because there's a lot of sweeping but vague and potentially dubious answers to where did you get this data from? How do we know this data is safe? Does that make sense?
Oh, it makes complete sense. So I'm going to these things like command crawl, book corpus, I used to train these models. And so command crawl is a dump of the internet. So that's where the jurisdiction where you train is going to be super relevant. And also an understanding of the expectations of the jurisdictions where you deploy is going to be relevant as well. And that's why, to be completely transparent, the US is really going very quickly in terms of training models and commercializing them. because a lot of people are relying on the fair use defense for the use of copyrighted materials to train the models. And then in terms of deployment, you kind of have two things going on. Certain providers of AI technology are saying, hey, I'll indemnify you if you have a copyright issue. I indemnify the customer. Or customers are themselves relying on like fair use. In other jurisdictions like the EU, and we're going to see that in a minute, certain jurisdictions place a lot of importance around disclosures of training materials. Like if you take Llama, this is the extent of the disclosure by Meta about the data that's been used. So they tell you it's been trained on 15 trillion tokens. A token is like it's a mapping of a word to a number, if you will. And so from publicly available sources, your guess is as good as mine in terms of what are these publicly available sources. And they say publicly available because they rely on the fair use defense. And they feel comfortable because they think their training is a transformative action based on the data. So they feel that they have a robust defense. Now, other jurisdictions are playing, facing restrictions or creating transparency requirements in terms of when you deploy AI there, like the EU. And so Meta has announced recently that they won't deploy their models in the EU. So Shane, I think you're exactly right. And so I think the purpose here is, I'm not going to give you like a magic wand and say, this is how you navigate the issue. I think governments are going to be under pressure to change their regulations to make possible the deployment of AI. Otherwise, these countries and jurisdictions are going to lag behind. And we're going to see in a minute where I think it's going, at least in terms of data and perhaps other things, and see whether there is like a pattern that emerges so that companies can prepare themselves in terms of the policies, the processes that they need to put in place to be ready when these regulations kick in and when it's mandatory to comply. Is that making sense, Shane? I'm answering the question.
Absolutely, absolutely.
Yeah.
Thanks for summarizing that. It's a key thing on people's mind.
No, I understand.
Yeah.
Yeah. I mean, that's the whole point. And so, to your point, so you build these things so that you are going to have to commercialize at some point. And commercializing means you're going to have to give people access to your technology, and there are kind of different models. And so this is again, super simplified. This is, you're going to, if you read what's available out there, you're going to see other things. But at a very, very high level, you can, of course, deploy your model like in the cloud. And so you're going to decide, which region you're going to host your model. Is it going to be hosted in, the US? Is it going to be hosted in Japan, which has a reputation of being AI friendly, Shane, for some reason? Is it going to be in the EU, and which is going to create or has created a lot of obligations for AI when deployed in the EU? Is it going to be deployed on-prem, on devices? Another scenario, which it's a little awkward, but I call that AI to human to human. Let's say you are going to call a bank and to get a mortgage. And the bank, so the person you talk to is going to interact with the computer, and the computer is actually AI powered. And so now you are going to interact with a human. You don't know it's AI behind it, but you're interacting with AI. The human is just talking to you, but the computer is making the decisions. So that's actually a scenario that is going to be of AI use that is going to trigger obligations in certain cases as well. We're going to see an example. And then you're going to have, as a company, you're going to have two roles. You're going to be either you're going to train AI and build AI, create these models, or you're going to take an existing models, perhaps tweak it and deploy the product with it. So like if you're a bank and you want to make a decision, maybe you're going to take an existing LLM and deploy that to make the decision about mortgage or whatever, and guide the your employee in terms of how to answer these questions. And so why does that matter? Because jurisdictions around the world are creating, let's just call it transparency requirements in terms of how you're going to describe the models that you ship, the models that you deploy or commercialize in their jurisdictions. So I have documented everything. It's not going to be, don't rely on this to make decisions. This is just for information purposes. Go to the actual text to make your decision on in terms of what are your obligations. But just to give you a sample, so California yesterday or the day before just announced, just approved, it was signed by the governor, a regulation about the training data transparency for generative AI. So to your point, Shane, I think some companies will have to update the materials they provide. The US federal government has also provided, so not regulation, but guidelines. So NIST, the Standard Institute, has provided a AI risk management framework with certain provisions that I think are relevant in that case. The EU has, of course, issued the AI Act. It's in force. The first obligations kick in August 1st, 2025. I think the bulk of transparency obligations are going to kick in 2026. Japan MITI has issued guidelines relevant to that particular aspect. And then the G7 has also issued principles, the Hiroshima principles, which deal with this issue. I'm just going to skip all that. I have a table summarizing everything, so we can take a few minutes to go over that, and then I want to cover some other aspects. But I think the key takeaway here is that if you commercialize AI, regardless of whether you are a provider of AI, so you train the model and you are offering it to others, or you are a deployer of AI, so you're taking a third-party model and you are commercializing a product with it, you are going to have some level of a transparency obligation. You're going to have a requirement to disclose some level of information about the data that was used. And maybe you don't know, so you're going to disclose what you know, but you're going to have to do something. And so, managing the supply chain of these components and figuring out these aspects is going to become really critical so that for your ability to comply with these requirements. And, from this short sample, it looks like, and I don't know China, I don't know, all of the others, but it looks like there is like this trend around transparency. And so you have variations from one jurisdiction to the other in terms of what needs to be disclosed, which, depending on if you are a provider or a deployer, your obligations are going to vary slightly, but it's, at the end, you're going to have to track these things. So there is a summary here, and just to give you a sense, you're going to have obligation to disclose the origin of the data you used or that was used to train the model. So, for instance, the name of the data set, like common crawl. If common crawl was used, I think people will have to disclose that they used common crawl. The name of the provider, the modality, is it text? Is it video? Is there synthetic data in there? How did you how was the personal information handled in the data set? So really the origin information, to your point, Shane, that's really where does the data come from? And then some jurisdictions have also placed obligations to disclose what did you do with the data? Did you clean it? Did you anonymize it? Did you remove the personal data? How did you handle copyright information in there, if at all? Like, what did you do to make the data fit for purpose in terms of the AI system you're building? And so, these requirements vary from one jurisdiction to the other. If you want the final answer, please refer to the legislation for the exact obligation. This is a very high level summary. This is probably full of mistakes, but some jurisdictions have a clear disclosure requirement. Others have just say, oh, this is a good idea. like the MITI AI guidelines. They say they recommend you establish a situation that allows the origin of the data to be traced, whatever that means. Shall we have I think we have 5 minutes left, Shane. Shall we move on, or are there any
Oh, yes. No,
questions?
no, absolutely. Absolutely. And, we can take some extra time. But I did notice, oh, Victor's got a question. So we should take that, I think. Victor,
Yeah, good question. Yeah, great presentation. Thank you. So, one question I actually this came up actually one time. Like if a organization, open source organization, use an open source model, which at this point do not have all this documented data sets information. Um, so if there are some proprietary or even open source code, for example, that's generated from this, and then is the user of the model are the
Yeah, you're asking like Copilot, for instance, GitHub Copilot, or the LLMs that
yeah
generate code. Yeah, I
yeah
mean this,
let's say it's an open source one, like open source Copilot.
but there's no such
Some
thing though. Uh,
yeah, I'm saying something similar, something, but it's open
yeah, yeah,
source, right?
yeah. I
So
mean,
and then
so I think so I don't have a great answer for you. I think every company, and this is not, we are just discussing here, so I don't know but I think like in general, every company will have to figure out, the level of risk they feel comfortable taking on. And it's kind of the point I want to make in the next section here. So maybe, yeah, but that's, in a nutshell is, I think you have to decide, because it's going to be a balance between speed and, like safety from illegal risks. I don't have a great term, but and so each company is kind of deciding how to navigate that one. But yeah, I mean, this computer generated stuff, it's very murky, and it's going to be very specific. So for instance, going back to the New York Times example, New York Times really came up with a prompt, very, very, very specific, to tweak the model to generate their article. But if you use the model normally, like everyone else, you wouldn't have the New York Times article. You would have just a summary of it or whatever. But it depends also how you're using these things, and that's kind of something that these model providers do. They say, oh, if you use it in a way that actually tricks the model into creating the infringement, then they're not covering you. I think that's my understanding. But if you are using the model, in a normal way, whatever that means, then you're probably fine.
yeah, so even if the model is created before the law is created, it doesn't automatically give the user the right to use
Well,
copyrighted
no,
information.
I don't think so, because the provider, took stuff that was out there, and then transformed it to give you the model, and then you use it, but there was no, you didn't have, you have no license from the original content owner. You may not know who the original content owner is, and so it's kind of a legal void right now, right? So each company is deciding. And so copyright is one issue, but for instance, in image data sets, you have sometimes other issues than copy. You have copyright, but you may have things like child, abuse materials in image data sets, because they try to get everything. And so now all of a sudden you have other issues that are popping up. You may have privacy issues in there as well. And so let me go to that particular section, and then we'll see if that helps answer your questions. So how do you manage these things? And so I think the first step is, all the regulations around the world are evolving quickly. I wouldn't be surprised if actually the EU backtracks in a way a little bit, or if they find a way to make it easier to deploy. We'll see. I mean, there is this kind of, so in California, they had come up with super stringent requirements for AI that was going to impact open source in a very negative way. It got vetoed by the governor like a week ago. So you have a lot of back and forth around regulation of AI and so on and so forth. However, there are, I think, a few capabilities that companies, they want to be ready because there are going to be some regulations for sure. I think there are some capabilities that companies can start implementing today that will help them down the line be ready for what may come up. And so just a few examples of scenarios that I think are going to be relevant. For instance, you may want to use only compliant data sets or models in your AI systems. And by compliant, I mean compliant with your own policies. And so to do that, you're going to have to, I call that key enabling capabilities. What are the things you need to have in place to be able to implement, to be ready for that particular scenario of, using things that you want and not things that you don't want. So you're going to have to define profiles for acceptable data set characteristics versus intended use. And that's something that you find also in open source. You very often define, you have a list of intended uses in terms of how you want to use these components, or like the products that you want to build with them. Is it internal use? Is it distribution to the end user? And so on and so forth. AI, you have slightly different taxonomy of intended uses, but it's the same concept. And so you want to have these profiles of acceptable data sets, characteristics for this intended use. You want to have an accurate catalog of data sets or models so that you can quickly decide which one fits your profile and which ones don't fit your profile. And that's one of the things we try to provide a catalog of data sets with relevant information. You want, of course, to have in place a review process so that when your data scientists want to use something, you can say yes or no, basically, and why. Another scenario is you want to be able to create reports for your AI system. And so basically, you want to be able to tell, which data set has been used in that system. As much as if you don't know, then you don't know. You can't make up the information. But if the information is out there, I think you will want to be able to leverage the available information and put in your documentation. So again, I think you need to have a catalog of these assets that you can easily leverage. You will want to have an internal system, basically tracking like an inventory, if you will, tracking which asset gets used where in your models and in your products. And you also want to have, and maybe Shane, that's maybe somewhere where OpenChain, perhaps in collaboration with others, like work on maybe not a standard, but some kind of specification for these reports. Like what kind of information are you going to put in there? And there are things that are available out there that we can use. Another scenario, which is frankly very common and can be super scary, is be able to address an adverse event in the supply chain. By adverse event, I mean, let's say you have an injunction about the use of a data set. Let's say Common Crawl has to remove certain materials from the data set, and so they issue a new version. And so you have to maybe retrain, or you have to detect where the previous versions were used. Or let's say you have child abuse materials in some data, and you need to detect that event and adjust your products based on that. So you want to detect it and be able to remediate. And so we can see similar capabilities coming into play. If you drill down a little bit on one scenario, I would, you can do the same thing for each scenario. But one of the ways in which you can structure that is, first start thinking about the policy that you want to put in place. Like what are the, these big drivers of a decision internally? So what are the profiles of these data sets? What kind of authority do I need for approvals and deviation? If something perhaps fits as a profile, maybe you have a lower level of approval. If something doesn't fit, maybe you want to provide an escalation mechanism. I think you want to set in place some processes so that people know what to do. one of the key elements is to define your risk management posture, speed versus safety, like compliance. You want to go fast. You want to make sure that everything is perfect, and perhaps lose some competitive edge. Your processes are going to reflect your risk management appetence and posture. One way of doing it is to have a balance, what I call like a balance posture. So you have safe profiles of that data sets, you decide what it is, but then you create a fast lane for that. And so that's where if you have access to a catalog where you can quickly isolate the, like safe profiles, like, open source license and publicly available and no personal data, what have you, then maybe you define that in the fast lane. You have a simpler process for those, and then you create a review for the others. You want to define what to document when and where do you want to place that information. So what are the compliance artifacts that you want to track over time and where? Yeah, and so the document side is just a few tricks. What do you need to track? How are you going to designate things? What standards are you going to use? So you have standard for model cards, dataset cards that are used to describe these things. They can be relevant. SPDX has recently released a specification for AI bills of materials that also cover data. So you have the model and the data supporting the model. Yeah, and that's more of the same. So I think that concludes my presentation. We have just a few minutes for questions.
Well, I guess the final question is, when it comes to looking ahead, we've seen, I think, some hints and directions in your presentation. For example, maybe the EU's stance will evolve over time. One thing that is pending, I suppose, is the question of regional collaboration or regional influence. And, with something like GDPR, when the EU took a stance, it had a ripple effect across the whole world. So I guess there's an open question for people with the EU AI Act as the first step. What's the chance that the EU will turn up the volume on AI regulation?
So but there is a new government now in the EU, new commission, with Thierry Breton being out and being pushed out, actually, some say. So I think you're going to have a very different dynamic with AI than you have with GDPR. So I think that's why I didn't want to leave the audience with the impression of how the EU is going to set the model and the rest of the world will follow. I don't know what's going to happen. I think there are, however, some common elements that are emerging. And I think companies need to prepare themselves for these common elements. And that's kind of what I'm trying to do here I think these scenarios are going to be relevant no matter what. Each jurisdiction is going to have different views in terms of what needs to be disclosed, but something will have to be disclosed. It's extremely unlikely that you get away without disclosing anything in terms of what went into your AI system. Very unlikely. So, I don't know the level of details, and that may evolve over time, but I think preparing oneself for these scenarios is probably the smart thing to do at this stage.
That's a very good summarization, and thank you so much, Nick, for this presentation. We'll be taking this live on the recorded platforms very soon, probably end of week or early next week. And we look forward to making sure our audience has access to this valuable information. And what can I say? But thank you for helping to fill out a very important part of our AI webinar series. And
absolutely, my pleasure.
This is step one for us. We'll be back to talk about these data issues again, I think sooner rather than later. So, Nick, I'm looking forward to this being the beginning of our collaboration.
Same here. Looking forward for, whatever next steps are relevant.
All righty. Have a beautiful day. And for those listening, likewise. And for those on the recording, wherever you are, do leave a comment. Let us know what you're thinking. Take care all. Be well. Be safe.
Bye-bye.
All righty. Take care.